All right, guys, so this is our last foldable for this section, and we're going to put this together like we just did our last. So remember, you're going to cut along this line to where you get like two half sheets, then you're going to put them together in proof number order, and then we're going to fold along this line, kind of put them together, and then I put a couple staples in here too just to keep it together, and it's going to be like a little booklet. Okay, so these are CPCTC proofs. Okay, yes, this is an acronym that stands for something. We didn't just make up some random word. So CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so CPCTC. Corresponding parts of congruent triangles are congruent. So basically, we've used this before, we just didn't know what it's called. That we know that if two triangles are congruent, we know that all corresponding parts have to be congruent. So if I'm told that this triangle here and this triangle here are congruent, you immediately says, well, yeah, that means that this side and this side are congruent. And then, you know, this side and this side are congruent. And also this side and this side are congruent. Well, that also means that this angle and this angle are congruent. This angle and this angle are congruent, and this angle and this angle. Like every piece or every corresponding parts, all corresponding pairs are congruent to each other. Okay, so we use this after we prove triangles are congruent. Okay, so use only after we have proved two triangles are congruent. Okay, they have to be congruent. Two triangles have to be congruent in order to use this. But after we know they're congruent, then we know that every piece or every corresponding part of them will be congruent as well. All right, let's look at proof number 1 here. Okay, so A is the midpoint of Rn. So A is the midpoint of Rn. That's given. Okay, and then Rg is congruent to Ng. That's given as well. Okay, well, let's go back to A is the midpoint of Rn. Well, that means that Ra has to be congruent to Na. Right? Ra has to be congruent to Na, and that's just by the definition of midpoint. Okay, and immediately when you've seen this, you should have seen that, yep, they share this side. This side is a part of both triangles. So I can say AG is congruent to AG by the reflexive property. Okay, well now I've shown that all three sides are congruent to all three sides of the other, so I can say the triangles are congruent by side, side, side. Okay, now because I know these triangles are congruent, now remember, I just proved they're congruent because I proved that all three sides of one are congruent to all three sides of two, and the side, side, side congruence theorem tells us we don't have to know anything about the angles if we can prove that all three sides are congruent, which we just did. But because I've shown that these triangles are congruent, I can now say that the corresponding parts have to be congruent. So that means that triangle ARG, so this angle here, angle ARG is congruent to angle ANG because they're corresponding parts, and corresponding parts of congruent triangles are congruent. That's where CPCTC comes in. And remember, this always comes after we've shown that the triangles are congruent. All right, let's look at proof 2. Okay, it tells us that JL bisect bisects angle KJM. So this angle is bisected. Okay, we'll come back to that here in a minute. That's given. And angle K and angle M are congruent, so I'm just going to put a big green swoopty. All right, now let's go back to JL bisects KJM. Well, if it bisects it, what does it mean to bisect an angle? Okay, well, when we bisect an angle, we cut it into two congruent angles. So I can say that angle KJL is congruent to angle MJL by the definition of bisect. So if I mark it, that would mean that this angle here is congruent to this angle here. Okay, now notice they share this side. So if they share a side, we can use the reflexive property. And notice I can put JL, J is last, JL, J is last. So I can just say JL is congruent to JL, or I could say LJ is congruent to LJ. That's the reflexive property. Okay, now I've shown that two angles and one side are congruent. So the question is this side here between the two angles, or is it not between the two angles? It is not between the two angles. So we would use the angle side congruency theorem. Okay, now because we've shown that they're congruent, we know that all corresponding pieces must be congruent as well. So that means this KL has to be congruent to ML by the corresponding parts of congruent triangles are congruent. So once again, it comes after we say the triangles are congruent. All right, let's look at proof number 3. So we know that SY and EK are congruent because that's given up here. And then we know that KE, so the ones we just marked in SY, we know they're parallel as well. Okay, so think of two lines being parallel. And then notice we have this KY as the transversal. So we may use that. All right, so then we're saying that angle 2 is congruent to angle 3. So how do we know that angle 2 and angle 3 are congruent? Well, guys, isn't angle 2 like right here and angle 3 like right here? And aren't those alternate interior angles? And the alternate interior angles theorem tells us that alternate interior angles are congruent as long as the lines are parallel, which we know that they are. Okay, now, number 4, we're going to use the reflexive property. So what piece do they share? Well, they share this side right here. Okay, so let's be careful of the order here. I can say KY is congruent to, so KY, so KY, so first and third is congruent to first and third YK. So here I do have to flip them to make sure they're in the same order as the congruency statement. And that's the reflexive property. Remember, YK is the same thing as KY. Okay, well now if I look up here, I have two sides and an angle. The angle I know is between the two sides, so I can say the triangle is congruent by the side angle side congruency theorem. And because they're congruent, guys, I can say that all corresponding parts are congruent, and angle 1 and angle 4 are corresponding parts. So I could say that corresponding parts of congruent triangles are congruent, and therefore angles 1 and 4 are congruent. And notice this comes after I have shown two triangles are congruent. All right, I want you to go ahead and try to do this one on your own, and then we will go over it. All right, let's go over this. All right, so we're given that JL bisects angle KJ or KLM, which is right up here, which tells me that these two angles are cut into congruent angles, which is right here on number 3. Okay, I'm also given that KL and ML are congruent, so I've highlighted those both in purple. And now notice they share JL. JL is a part of both of the triangles, so I can use the reflexive property and just say that JL is congruent to JL. Okay, and from there I have enough to conclude that the two triangles are congruent by side, angle, side. The angle that I know is between the two sides, so we can use side, angle, side. Now I put triangle JKL is congruent to triangle JML, but if the order of your first triangle, so if JKL is switched up, then the order of your second has to be switched to match it. You can write it in several different ways. Just make sure the order of the second is in relation with the order of the first. And because those two triangles are congruent, all corresponding parts of those two triangles are also congruent. So by CPCTC, I can say that KJ is congruent to MJ, and that is my proof. All right, I want you to go ahead and try this proof number 5 on your own, and then I'll go over proof number 6. We can do that one together. All right, so let's go over proof number 5. So we're given that WO and SK are parallel, okay? And we're also given that they are congruent. So I'll go ahead and mark those in green, and I've put in the arrows to show that they're parallel as well. Now, because they're parallel, so I have two lines that are parallel, and I have this transversal that goes through them, this angle and this angle are alternate interior angles, which are congruent, which is angle W and angle K. Now, if you wrote down angle S and angle O are congruent because of alternate interior angle theorem, that is correct as well. You could have done either one of those pairs. Okay, so I have angle W is congruent to angle K by the alternate interior angle theorem. If you have angle O and angle S are congruent, that's okay too. All right, now we've got to state that we have two vertical angles. So I've done that here in black, and that's just by definition of vertical angles. And then because we know they're vertical angles, we know they are congruent by the vertical angle congruent theorem. So these always go in this order, guys. So you have to state that they're vertical angles, and then you can state that they're congruent. So you state they're vertical angles by the definition of vertical angles, you state they're congruent by the vertical angle congruence theorem. Okay, and now I have angle, angle, side to show the triangles are congruent, and because they're congruent, that means all corresponding parts are congruent, which means that OR is congruent to SR by CPCTC. All right, so let's look at this here. So I have AE and BD bisect each other at C. Okay, so anytime they bisect, that means they're cut into two congruent parts. Okay, so that means AC and EC are congruent by the definition of bisect. And I know BC and DC are congruent also by the definition of bisect. Okay, and then I know that ACB and ECD are vertical angles. That's just what we talked about, definition of vertical angles. And then it always follows that angle ACB is congruent to angle ECD by the vertical angle congruence theorem. So I'm going to go ahead and mark that and that as well. Okay, well now notice I have two sides and an angle, and the angle is in between, so I can say that triangle ACB is congruent to triangle ECD by the side angle side theorem. Okay, now because they are congruent, I can use CPCTC to say that all corresponding parts are congruent. So angle B is in the last column, angle D is in the last column. So angle B and angle D are congruent by CPCTC. And notice I've used that after I've shown that the triangles are congruent. And because angle B and angle D are congruent, guys, so if I have this, and I know this angle and this angle are congruent, well, guys, these are alternate interior angles. And if you think back to chapter 3, when alternate interior angles are congruent, that means the lines have to be parallel, and that is the alternate interior angle converse theorem. And that is it for that booklet.